Now we have a equation for the position x, which is x equals to 5 minus 9t plus 6t squared minus t cubed. To find the velocity, we derive it once, which is minus 9 plus 12t minus 3t squared. Minus 3t squared. And then to find acceleration, basically deriving it the second time, so give us 12 minus 6t. So that's the complete set of equations of the motion. For the second part, looking for the initial velocity. That's what we find, because for direction, we just have to find the sign of the initial velocity. Now, we have already found the equation of velocity, so which is minus 9 plus 12t minus 3t squared. And what it means by initial is when t equals to 0. So equals to minus plus 12t, correction, 0 minus 3, again 0 squared. So it gives us obviously 12 times 0 is 0, 3 times 0 squared is still 0, so it's minus 9. It's a negative velocity, so it's moving towards left. Now the third part, look for points when it's stationary. Well, what it means by stationary? Sorry, changing directions. Changing directions is when the velocity comes to a 0. Obviously, look at this equation here. We can see a parabola, an upside down parabola. This is the velocity, the change of velocity over time for this particle. So this is t and this is x. Now it means that it starts, the velocity at the start is negative 9. So obviously it's negative 9 here. And then velocity will change until this point when it becomes stationary. All this area, this velocity is negative. It becomes positive in this region, and then it becomes negative again when it's past this point. So these 2 points, two stationary points where the velocity is 0, is when the particle changes its direction. So we already have the velocity equation, which is minus 9 plus 12t minus 3t squared, and we just have to find the roots. Basically, we have to find the roots for this parabola here, and they obviously cross method, minus 3 1 3 minus 3, and it gives me x equals to t minus 3 minus 3t plus 3. So if velocity is 0, t minus 3 minus 3t plus 3, it gives me t equals to 3 or t equals to 1. So we can safely say that it's 1 here and it's 3 here. Now, the location of the particles at these 2 points. Obviously, we have the t here. We just have to substitute them back into the original equation, the position equation. So we have x equals to 5 minus 9 plus 6, 1 squared minus 1 cubed. Yeah. So it should give us 5 minus 9 plus 6 minus 1. Give us 5 minus 9. Give us 1. And for the second one, 5 minus 9, 3 plus 6, 3 squared minus 3 equals to 5 minus 27 plus 3 is 9, 6, 54 minus 27, and so minus 27 plus 54. This bit cancels out, which gives us 5. So that's our locations for the particle where it changes direction. Now, last bit, we can use all the results from here to find out how far it actually traveled. So we have, firstly, let's find the initial location. So x0 equals to 5 minus 9, 0 plus 6, 0 squared minus 0, 3. And that gives us 5. So at the, So at the start, when t equals to 0, the location of the particle is at 5. Then at t equals to 1, when it comes to stop for the first time, the location has changed to 1. So this one, when t equals to 1, x equals to 1. So 1 minus 5 equals to minus 4. We take the absolute value. So it traveled 4 units of distance from t equals to 0 to t equals to 1. So this is from t equals to 0 to t equals to 1. Now from t, we have to find out from t equals to 3, and x is 5 again, and then 5 minus 1 equals to 4. So this bit is from t equals to 1 to t equals to 3. So 4 plus 4 equals to 8. So what it means is that the particle traveled from t0 to t1, it traveled from 5 to 1, and then from t1 to t3, it traveled from 1 to 5 again. I hope this answers your question.